All right, now we're going to cover Chapter 5. Starts on page 47, and this is an introduction to the trigonometry functions. So far, we've covered chapters 2, 3, and 4, and specifically chapters 3 and 4 gave you some tools to help you solve for unknowns in triangles. And what do we mean by solving a triangle? Well, with a given right triangle, you might be given certain information like the length of a side or the value of an interior angle, and maybe you want to solve for those other unknown sides and angles. So in some cases, you could use your knowledge of the sum of interior angles. You can also use the Pythagorean theorem, but those two tools may not be enough to solve for what you need to solve for. So we're going to cover 3 trigonometry functions. Those 3 functions are sine, cosine, and tangent. You'll often see them abbreviated. For instance, on your calculator, sine will be shown as sin, cosine as cos, and tangent as tan. Now in this chapter, all we're going to do is describe the sine, cosine, and tangent. We're not actually going to use them in problem solving yet. Once we get to chapters 6 and 7, then we're going to talk about how do you use these trigonometry functions to solve for the length of unknown sides or to solve for the value of unknown angles. So let's start off with the sine function. So let me recreate the triangle that's on page 47. So you have this right triangle, and each vertex is labeled ABC, and we have one angle is labeled angle theta, and they have a length of 6 inches on this side and 12 inches on the hypotenuse. So all we're going to do now is define the sine function. So the way the sine is defined is the sine of a given interior angle is equal to, so really what we're talking about here is we're comparing the length of sides. Trigonometry is good at comparing the length of sides within a right triangle. So what we're going to do is for the sine, what the sine function will do is for a given angle, in this case we're talking about the angle theta, it's comparing the length of the side opposite this angle, so the 6-inch side is opposite the angle theta, and it's comparing the length of that side to the hypotenuse, which is the side opposite the right angle. So the sine of that angle is equal to the length, this is the length of the sides, the length of the opposite side compared to the length of the hypotenuse. And for a given angle, all right triangles with a specific given angle will have the same ratio of sides, no matter, as we talked about, no matter how big or small a triangle is, if it has a certain value for an interior angle, the length of the side opposite to the hypotenuse will always be the same, and your calculator knows that. So let's keep going here just to show you, complete this calculation. So the sine then of this angle is equal to the length of the opposite side, which is side AB, divided by the length of the hypotenuse, which is side AC. We can plug in those actual numbers. So this is 6 inches divided by 12 inches. Now you'll notice here that the units will cancel out. So this is one of those situations. Let me move the B out of the way here. So this is one of those situations where this is a calculation that will result in a number that does not have a unit. So 6 divided by 12 would be 0.5. So in this case, we have 0.5, unitless number. And again, at this point, we're not doing any problem solving. We're just defining what the sine is. Now, there is a note there at the end of page 47 which says, of course, in order for the units to cancel out, you have to make sure that the lengths of the sides are expressed in the same units. So if, for instance, if one side was expressed in centimeters and another in inches, you certainly have to do a conversion to get those lengths into the same units before that calculation was done. Now we'll go on to the next page and take a look at the cosine. All right, so the cosine function. Now we're looking at this triangle DEF. And let me recreate that here quickly. Again, we have an interior angle theta. And we have given lengths. This side DE is 13.3 centimeters, and then you have the hypotenuse of 15.4 centimeters. So now we're going to define the cosine. In this case, the cosine of an angle is the length of the adjacent side to the length of the hypotenuse. So you remember the sine was the opposite side, length of the opposite side by hypotenuse. In this case, it's the adjacent side compared to the hypotenuse. So if we look at this triangle, then the cosine of that angle compares the length of side DE, 13.3 centimeters, to the length of the hypotenuse side DF, 15.4. So it would be the length of DE compared to DF. Then we can plug in the numbers. 13.3 centimeters divided by 15.4 centimeters. Again, the units cancel out, and you're left with 0.86. All right, so that's the definition of the cosine. You can see an example at the bottom of page 48. This is a cosine example, cosine of a given angle beta. But this is one of those examples where, for whatever reason, the two known sides, JK and KL, are expressed in different units. The hypotenuse is 1.7 feet. The side JK is expressed as 9 inches, so you have to do a conversion. In this case, JK was converted from inches into feet. You also, as an alternative, you could convert the hypotenuse of 1.7 feet into inches. Either conversion is okay, just as long as both lengths have the same units. And then you can see in this case the value of the cosine is equal to 0.44. All right, so before we move on, we're not going to define the tangent quite yet. There's a few exercises that we can go through to practice these definitions. So if you could, do the exercise on page 49, which is asking you to determine the values of the cosine and sine of each of the two interior angles of that triangle. So I'll give you a few minutes to work through that. All right, so let's talk through this exercise. Okay, the first one is already partially done for you in the text. So I'm going to use some abbreviations here, and you may find this helpful so you don't have to write so much. You can just abbreviate the opposite side by writing down OPP, and the hypotenuse you can abbreviate with HYP, and it makes it a little quicker and easier. So the sine of angle beta is equal to the length of the opposite side divided by the length of the hypotenuse. The opposite side is length BC. The hypotenuse is the side opposite the right angle, so it's AC. And those values in the sketch are given to you as 4 feet and 5 feet. Units cancel out, and you're left with the numerical answer of 0.8. Which means that length B, the side BC is about 80% as long as side BC. All right, now cosine of that same angle beta, that's equal to this adjacent side. We can just abbreviate that ADJ divided by the hypotenuse. In this case, the adjacent side is side AB. The hypotenuse, once again, is AC. So that would be equal to 3 feet divided by 5 feet, or 0.6. We can take a look in the back of the text just to verify that we're on the right track. And that looks correct. All right, then we can go to the other angle, to the interior angle theta. So the sine is always opposite side divided by the hypotenuse. In this case, for angle theta, the opposite side is AB. The hypotenuse is AC. And then once again, 3 feet divided by 5 feet, which again is 0.6. Interesting development there that the cosine of the one interior angle is the same as the sine of the other interior angle, because they're both are the ratio of the side AB to AC. So we'll talk more about that in upcoming days. And then finally, give myself a little more room here. Cosine of theta then would be the adjacent side divided by the hypotenuse. Adjacent side would be side BC. Hypotenuse is AC. BC is 4. Feet divided by 5 feet, again 0.8. All right, so that's just a little practice in using the definitions of sine and cosine. All right, so I'll give you a few more minutes. Now take a look at page 50. Before we look at the tangent function, have a go at the exercise 5.2 at the top of page 50. And then as you work through 5.2, you can, after you do that, you can check what you've done in the answer section at the back of the text. All right, so hopefully you've had a chance now to work exercise 5.2 at the top of page 50. I'll leave exercise 5.3 for you to do as practice later, and right now what we'll do is we'll move on to the tangent function on page 51. So again, we're just talking about the definition. So here's the figure that's on the top of page 51. So tangent is commonly abbreviated TAN. So for this triangle, now the tangent of the angle has its own definition. It is equal to the length of the side opposite the angle divided by the length of the side adjacent. So for this triangle, the angle in question here is angle theta. The side opposite is side EF, and the side adjacent is side DF. So for this trigonometry function, the hypotenuse does not come in play. We're only dealing with the opposite and the adjacent sides. So in this case, the opposite side is EF, adjacent side is DF. So we can plug in the known information, 8.5 inches divided by 4.7 inches. Once again, the units cancel out, and the value is 0.58. So go ahead and have a go at exercise 5.4 at the bottom of the page, and you're asked to calculate the tangent of the two given interior angles, theta and beta. All right, so let's continue with exercise 5.4. So the tangent of angle theta is equal to the length of the opposite side divided by the adjacent side. Again, we're using abbreviations, OPP for opposite, ADJ in this case for adjacent. So in this case, for angle theta, the opposite side is side RS, and then the adjacent side would be ST. And RS has a length of 36 inches. ST is 15 inches. Units cancel out. And let's see what we have here. So that would be 2.4. So that tells you that side RS is 2.4 times as long as side ST. And then for the tangent of angle theta, this one is beta, right? We already did theta. So for beta, opposite side is side ST, and then the adjacent side is RS. So now you can see when you calculate the tangent of the two interior angles, they're actually just the opposite of each other, because for angle beta, side ST is opposite, but for angle theta, side ST is adjacent, and vice versa. So you can see it's just the inverse. So side ST is 15 inches, side RS is 36 inches, and let's see what that calculation is. So that ends up being 0.42. All right, so that shows you how you set up the tangent of a given right triangle. Okay, so now what I'll do is I'm going to leave the next two exercises for you to do on your own. That'll be on page 52, exercise 5.5 and 5.6. More practice in setting up the tangents, just like exercise 5.4. All right, if we keep going, now take a look on page 53 and 54 actually. So these are two exercises that now have you practice setting up for the calculation of sine, cosine, and tangent. So you're given a triangle and the length of two sides, and then you're asked to do the same thing as we did in previous exercises, is calculate the sine of beta, cosine of beta, tangent of beta, and the same for the angle theta. Now also take a look on page 53. You're given the length of two sides, so you're going to have to use Pythagorean's theorem to calculate the length of side dB, because that's not given to you. So you'll have to do that first, and then you can use dB as appropriate in the sine, cosine, and tangent calculations. And same thing for over on page 54. You're given the length of two sides, and you'll have to calculate the third side, and also watch for mixed units. You may need to do a calculation as well. So again, I'm going to leave those exercises for you to do for practice at the end of class and as homework, just for practice. And the way I'd like to wrap this up, I'm just going to wrap this up by covering page 55. Okay, just a couple of pieces of information on page 55. The top of page 55 is just a summary of what we just talked about. It just in condensed form gives you the definition of sine, cosine, and tangent. Then in the middle of the page, I heard some of you mention this the other day. Some of you who have been exposed to trigonometry before might remember this memory aid, which is SOHCAHTOA. Some people use this memory aid to remember the definitions of sine, cosine, and tangent in terms of which sides are used in the calculation. So this memory aid goes like this: SOH, CAH. So this is kind of an abbreviation that stands for sine is equal to the opposite over hypotenuse, cosine is equal to the adjacent over hypotenuse, tangent is equal to the opposite over adjacent. And if you could pronounce it as SOHCAHTOA. You can have it, you can get a tattoo. I'm sure the tattoo parlors would love to do this, and get a tattoo on your arm or your hand, so it would always be there. All right, and the last comment at the bottom of page 55 is just to let you know that we've covered 3 trigonometry functions, but there actually are 3 other ones. We're not going to cover those, but I'm just letting you know that they exist and what their definitions are. These 3, the secant, cosecant, and cotangent, are merely reciprocals or the inverse of the ones you've already learned here. So for instance, the secant is merely the inverse or the reciprocal of the sine, whereas the sine is the opposite over the hypotenuse, the secant is the hypotenuse over the opposite. So you might see a reference to these 3 in other textbooks, in other applications. We really don't have a use for them because as long as you can use sine, cosine, and tangent, there's really no apparent need for you to use these other ones. So let's just be aware of their existence, but know that you probably won't need to use them. All right, so that's the end of chapter 5. So you can go back and practice the exercises that we did not cover.